Question 1. The shot put is an athletics event in which competitors throw a shot as far as possible. The shot is a metal ball of mass 4 kilograms. One of the competitors releases the shot at a height of 1.8 meters above the ground and at an angle theta to the horizontal. The shot travels through the air and hits the ground at X. The effects of air resistance are negligible. This here, we ignore air resistance. The graph shows how the release speed of the shot V varies with the angle of projection theta. Here's our graph. Okay, so we're going from 0 to 2 in 1, 2, 3, 4, 5 steps, which means that one box equals 2 divided by 5, which is 0.4. Just a little note for myself. The angle of projection for a particular throw is 40 degrees, so state the release speed of this shot at this angle. 40 degrees, I'm going to get my ruler out, draw a line up from 40 to where it meets the line. There. I'm going to go across. One box below 12, so that's going to be 11.6. So this here is simply just 11.6 meters per second. Okay. Calculate the horizontal component of the initial velocity of the shot. So I want the adjacent. I've got the hypotenuse, I want the adjacent, so it's cosine. So V horizontal is release speed, cos of the angle, which is 11.6 times the cosine of 40. 8.886. So I've got 3 significant figures here and 2 here, so I would do 8.9 seconds. If calculate the vertical component, horizontal is cosine, so V vertical is going to be V sine of the angle times the sine 40. $7.5. Okay. Maximum height reached by the shot is 4.7 meters above the ground. The time between release and reaching this height is 0.786 seconds. We want to calculate total time, so I'm going to be asked to calculate total time between the shot being released and hitting the ground at X. Going back to the diagram, what we are told is that this point here is 4.7 meters above the ground. It took 0.76 seconds to get from there to there. So basically we want to know how long does it take to go from there to there. At this point, this is the maximum peak, so the vertical velocity is going to be 0 meters per second at the peak. And so now I've pretty much got all the information I need. I'm going to solve at this because we're dealing with height. That is vertical equals constant acceleration. So S U V T times negative up is positive. We're going from a height dropping down, which means that my displacement vector is pointing in the downwards direction. So it's negative 4.7 meters. My initial vertical velocity is 0 meters per second. Don't have that. My acceleration is negative 9.8 meters per second. I want to know the time. So I'm going to be using that S equals ut plus 1/2 at squared, so negative 4.7, 1/2 times negative 9.8 times t squared. Rearranging, multiply it by the 2, divide by negative 9.8, so I get negative 4.7 times 2 over negative 9.8 t squared. So t is the square root of all this, square root of negative 4.7 times 2, which is 0.98 seconds. Okay, so total time plus 76, which is 1.74 seconds. Okay. Part B, range for this up. Range is horizontal distance, so I just need to use SH is in a straight, BH, T equals two significant figures are diffused in the question. Using information from the graph, explain the effect of increasing the angle of projection on the kinetic energy of the shot at release. That's the graph. If my angle increases, my release speed is decreasing. If my release speed decreases, my kinetic energy will also decrease. So, the effect is kinetic energy decreases because as angle increases, the release speed decreases.